Hi students, we will be learning about the last quadrilateral that we're going to learn, which is trapezoids. There are also kites, which we can talk about, but I will not test you or formally teach you about kites. So we've learned about the parallelogram family, Papa Parallelogram with his kids, rectangle rhombus, and then their kid, the very symmetrical square. Now we're switching gears, talking about another very different quadrilateral, which is trapezoid. There are lots of vocabulary terms that go with trapezoids. So a trapezoid, it's a quadrilateral, but it only has one pair of parallel sides, whereas parallelogram, rectangle, rhombus, and square all had two pairs of parallel sides, just one pair. Okay? Down here, this is a trapezoid. Trapezoids do not have to be symmetrical. Most of the trapezoids you've seen up till now have been very symmetrical. They don't have to be. The only thing they have to have is one pair of parallel sides. Okay? Those pairs, or that pair of parallel sides, those are called the bases. So the bases are the two parallel sides, and those are always opposite each other. So, oops, I can't spell sides. Having some issues. Okay, so in this case, the parallel sides are, it looks like the top and bottom. Okay, those are your bases. So you always are going to have two bases, and they're going to be different lengths. One is always going to be longer than the other. If they were the same length, then the other two sides that are opposite each other, they would be also parallel. The way to keep them not parallel is by having these bases have different lengths. Which leads us to the legs. The legs are the sides that are not parallel. So that's this guy and this guy. The two slanted kind of sides. Okay, so we've got two bases, they're parallel, two legs, they're not parallel. Then we have these things called the base angles, okay? Base angles. So what base angles are, they are a pair of angles at each base. Let's write that down and then I'll show you what I mean. A pair of angles at each base. So each base has a pair, so there's actually 4 base angles altogether. An example of base angles, and I'm going to abbreviate angles, is this guy and this guy. Those are 2 base angles on the bottom base, but the top base is also going to have a pair of base angles. Okay? We cannot make any conjectures about their sizes relative to each other. Okay, so as of right now, we have nothing that's congruent to anything else. The only property we have is that we've got one pair of parallel sides. An isosceles trapezoid is a special type of trapezoid. And if you remember in an isosceles triangle, they have at least 2 sides that are congruent. Well, pretty much the same thing with the trapezoid. An isosceles trapezoid is a trapezoid where the legs are congruent. We'll say with congruent, I'm going to use the symbol legs. And there's a typo right below that. This says the base angles. It should say angles. Very similar, but a little different. The base angles of an isosceles trapezoid are congruent. So I will show you exactly what I mean in just a minute. We're going to do a little bit of discovery, and then we'll talk about all the things that isosceles trapezoid has. So when the legs, remember here the legs, when they have the same length, then we have a bunch of congruencies. Without those being congruent, we don't have any. So all of the problems we'll deal with trapezoids are going to be with isosceles trapezoids because we're going to better be able to set up equations because we have more congruencies. So let's look more closely at isosceles trapezoids. So here's a hypothetical. So the diagonals of an isosceles trapezoid have a special relationship, which we'll discover right now. So it says, first graph the isosceles trapezoid MATH by plotting the points MAT and H. So let's go ahead and do that quickly, real quick. The first point M is at 0, -2. That's right here. That's M. The next point is A at 0, 5. So that's up here. T is at 6, 7. I think it's there. Yes. And then H is at 6, -4. Okay, so let's go ahead and connect these so we can see our trapezoid. So it's isosceles. Remember, that means the legs are congruent. This trapezoid looks like it's drawn kind of sideways from the trapezoid we just looked at. The two parallel sides are obviously going to be these two because they're both vertical, which means they're parallel. So the legs that are the congruent ones are going to be AT and MH. The parallel sides, those are your bases. So it says first name the diagonals. So remember, in all quadrilaterals, if you connect opposite vertices, you will have your two diagonals. So all quadrilaterals have two diagonals. So our diagonals are segment MT and segment AH. Okay. So the first thing we're going to do is we're going to find the length of each of these. Remember, when you find a length of a segment, it's the distance between those 2 points. So we're finding distance. So for MT, we're using the coordinates, I'm just going to rewrite them, 0, -2, and T is 6, 7. It's real easy to accidentally use the wrong points. So MT has a length that's equal to the square root of the difference in our x's squared plus the difference in our y's squared. So our x values are the first two, right? The 0 and the 6. So we'll first subtract those. I'm going to do 6 minus 0. Remember, you can subtract in any order with the distance formula, plus the difference in my y's, which are 7 and -2. I can do -2 minus 7 or 7 minus -2. I'm going to do, let's do -2 minus 7, and we'll square that. Now we're going to simplify. 6 minus 0 is 6. Then we'll square that, plus -2 minus 7 is -9. And then we'll square that. 6 squared is 36. -9 squared is 81. Remember, when you square both of these, you should get two positive numbers. And then when you add those together, we're going to get the square root of 117. And 117 is prime, so that's not going to simplify. So there is one diagonal's length. That's MT. Now let's find the length of diagonal AH. Its coordinates are, let me write those down. For A, it's 0, 5. And for H, it's 6, -4. And I'm going to try to squeeze this in here. I'm using a different color so you can kind of separate these two. So AH equals, the difference in our x values are 0 and 6, so you can do 0 minus 6 or 6 minus 0. I'm going to do 6 minus 0 squared, plus our y's are 5 and -4, so 5 minus -4 or -4 minus 5. I'm going to do -4 minus 5, and then we'll square those. So we're going to get, I'm just going to rewrite this so it's not so disjointed. All right, 6 minus 0 is 6, so 6 squared, plus -4 minus 5 is -9, so -9 squared. Notice these are the exact two numbers we had on the other one, but we're going to keep going. 6 squared is 36, -9 squared is positive 81, and of course when you add those, you're also going to get square root of 117. So that's the length of diagonal AH. So what could we say about the length of each diagonal? They are congruent. And this is another really important property of isosceles diagonals. So the legs are congruent and the two diagonals have the same length. Okay, so diagonals are congruent. This is the conclusion that we can make. Diagonals in an isosceles trapezoid are congruent. All right, so let's try some examples. So we've got an isosceles trapezoid here. Decide whether each statement is true or false. Okay, the first one says that AC equals BD. AC is one diagonal's length, and BD is the other diagonal's length. And yes, in an isosceles trapezoid, those are congruent. So this is true. Woohoo! All right, the next one says segment AD is congruent to segment BC. Segment AD is congruent to segment BC because those are the legs, and they are also congruent in an isosceles trapezoid, so that's also true. C says segment CA and BD bisect each other. Those are the two diagonals. Diagonals do not bisect each other in a trapezoid. That is false. Diagonals only bisect each other in parallelogram, rectangle, rhombus, and square. If you look at our diagonals, what you will notice, let's keep talking about this isosceles trapezoid. There is a line of symmetry that goes vertically down the middle, just kind of like this. So basically, everything on the left and right match up. So while the diagonals aren't cut in half, what is true is these top two parts are congruent and these bottom two parts are congruent. But notice within a diagonal, the two parts are not congruent, if that makes any sense. Let's talk also about the angles since we're here. Our next example is about the angles. So in an isosceles trapezoid, because we have this symmetry on both sides, this base angle is congruent to this base angle, and these two base angles are congruent to these two base angles. Now notice, because we've got these parallel lines, our legs are kind of like transversals, right? So what we can also say is if I take an upper base angle with a lower base angle, let me get another color here. So like this angle and this angle, those are same side interior, they're going to add up to 180. Same with this base angle and this base angle, they're going to add up to 180. So opposite angles are not congruent, but the two upper base angles are congruent, the two lower base angles are congruent, and then an upper with a lower is supplementary. They're going to add up to 180. So those are some of the angle properties of isosceles trapezoids. Let's look at this next example. This is also an isosceles trapezoid. It says the measure of angle EDO, that's this angle, is 110. The measure of angle DEN, that's this angle down here, is 15x minus 5. I just said those are supplementary. They're going to add to 180 because those are same side interior. So we want to make an equation that shows that they add up to 180. So we'll say 110 plus 15x minus 5 equals 180. And then this is the equation that we'll solve. So to solve this, on the left, we want to combine like terms. 110 and a negative 5 combine to make 105 plus the 15x equals 180. We'll move all our constants to the right, so we'll subtract 105 from both sides. So 15x equals 180 minus 105 is 75. Then we'll divide both sides by 15. So x equals 75 divided by 15 is 5. So x has a value of 5. All right, here's another one. Again, we have an isosceles trapezoid. PR has a length of 3x minus 7. That's one diagonal. TA has a length of 20. That's the other diagonal. Remember, diagonals are congruent. They are equal in length. So that means I can put an equal sign between these two expressions. And then this is what we'll solve for x. So to solve for x, we'll move all our constants to the other side, the right side. We'll add 7 to both sides. So 3x equals 20 plus 7, which is 27. Then we'll divide both sides by 3. So x equals 9. Easy peasy. All right, another new word we're going to learn about is this word median. Triangles have a median, so do trapezoids, but we're going to specifically just look at trapezoid right now. So a median, it is a segment that joins the midpoints of the legs of a trapezoid. It is also parallel to the bases. So this does not specifically apply to just an isosceles trapezoid or not. It can apply to any trapezoid. So let me go ahead and write that definition again. So a segment that joins the midpoints of the legs, it's parallel to the bases. So if this is the midpoint, can't spell, of this left leg, right? Here's the midpoint. And then this guy is the midpoint of this right leg. So notice my legs aren't necessarily congruent. Then the segment that connects them, this guy, is called my median. Okay? Remember, the top box and the bottom boxes represent our bases. So this is a base and this is a base. The median is equidistant from both bases, and it's also, don't forget, parallel to the two bases. So these three lines are all parallel. Okay? Base, median, base. The way to find the length of the median is equal to base 1 plus base 2 divided by 2. Basically, we are averaging the bases. We are averaging the bases together, okay? It's going to have a length right in between the base lengths. Okay, remember the bases are not going to be equal in length, okay? This is kind of like when we found a midpoint. So let's go ahead and look at some examples of this. All right, for these examples, we're going to use this picture at the right. The numbers, we're going to reuse each picture. So the numbers from one problem aren't going to go into the next problem. So we'll just erase our picture each time. But we do have a trapezoid. It says EF is the median. So what that means is E and F are the midpoints of those two legs, which means these two segments are congruent, these two segments are congruent. These three are parallel, okay? EF is the median. It's going to be the average of the two base lengths of DC and AB if we need to find that, okay? So let's go ahead and look. So A says AB is 25, DC is 13. So 25 and 13. Okay, so basically we're going to average those together and that'll be the length of EF. So 13 plus 25 divided by 2. 13 plus 25 is 38. 38 divided by 2 equals 19. EF has a length of 19. See how easy that is? It's right between. Notice that 19, it's 6 between 13 and 6 between 25. I misspoke. 19 is 6 units from 13 on one side and 6 units from 25 on the other side. So it's kind of like when we were doing midpoint. All right, let me erase these. I'll try another one. All right, so for the next one, it says AE equals 11. That's this little part. FB equals 8. AD equals what, and BC is what? So AD is the whole length and BC is the whole length. So remember, those two halves are congruent. So if that's 11, that's 11. If that guy's 8, this guy is 8. So you're just doubling it. So AD is going to be 22, 11 plus 11. BC is going to be 16, 8 plus 8. Pretty easy, right? All right. Let's go ahead and look at the next one. Trying to recycle this. Okay, the next one. AB equals 29. EF is 24. And DC equals what? So this is where we can do like the difference thing, right? Remember how we did this with midpoint? 29 is 5 from 24. So if I go 5 on the other side of 24, I'm going to get to 19. 24 is right in the middle of 19 and 25. See how easy that is? Now, when it's not easy is when you have expressions. So take a close look at this one. You definitely will probably see a problem like this. It's not hard. It's just a little tedious. So let's see what it looks like. So AB is 7y plus 6. EF is 5y minus 3. And DC is y minus 2. Solve for y. Okay, so what I know that EF, which is 5y minus 3, is equal to the two bases averaged together, or added and divided by 2. So the top base is y minus 2, plus the bottom base, which is 7y plus 6, added together, divided by 2. So here's my equation. Just to reiterate, the median equals the two bases added together, divided by 2. So to solve this equation, I'm going to first suggest getting rid of that 2 denominator by multiplying both sides by 2. And what's going to happen, this 2 denominator is going to cancel with this 2. So on the right side of our equation, we'll just have that numerator. On the left side, we'll have to distribute that 2. So on the left side, 2 times 5y is 10y. 2 times negative 3 is negative 6. On the right side, it's just the numerator. But let's go ahead and combine some like terms while we're at it. The y and the 7y, remember this is like 1y, can combine to make 8y. And the negative 2 and the 6 can combine to make 4. Now we'll get all our y's on one side, all our constants on the other. I'm going to move the 8y to the left by subtracting it from both sides. 10y minus 8y is 2y. And then we have minus 6 equals 4. And then move my constants to the right by adding 6 to both sides. So we get 2y equals 10. Divide both sides by 2. Whoops, I'm running out of room. Can't really write down there. It's kind of not working. So y equals 5. So when you have expressions, it's not as easy to kind of count the same number on either side of the median. You have to set up the equation. The median equals the two bases added together divided by 2. Whew. All right, here's a few more. Example 5, find the value of x. X is going to be right between 24 and 34. You can either think, what is that number? Like if you had a number line counting in, kind of like you found the median back in junior high. Or remember, you can add the bases together. 24 plus 34, and then divide by 2. 24 plus 34 is 58. 58 divided by 2 is 29. So that median has a length of 29. And just to check it, 29 is 6 below 34. Sorry, 5, can't add. And then, whoops, 5 below 34. And 5 above 24. So it's right in the middle. That's its length. Example 6, this is where we have to set up an equation because we have an expression. So our median is 2x plus 3, and that length is equal to the average of the two bases, which are 12 and 30. So we're going to add them and divide by 2. So the cool thing is on the right, we don't have, we just have numbers, so we can actually simplify that. 12 plus 30 is 42. 42 divided by 2 is 21. So I'm going to simplify this equation to 2x plus 3 equals 21. So 21 now is the length of my median. I have to just solve it now to find x. So we're going to move our constants to the right side by subtracting 3 from both sides. 2x equals 18. Then we'll divide both sides by 2. So x equals 9. All right. Let's go ahead and review the properties of trapezoid. All right, so to summarize, for all trapezoids, and I drew a trapezoid at the bottom we can mark up, they all have one pair of parallel sides. Remember, those are your bases. So this guy and this guy are parallel. Those are your bases. The other thing is that the upper and lower base angles on the same leg are supplementary. So this angle and this angle add up to 180 because they're on this same leg. And then this angle and this angle add up to 180 because they're on the same leg. This leg right here. Okay, those are same side interior. Okay, now, let me get rid of that really quick. Now let's talk about a specific type of trapezoid, and that's the isosceles trapezoid. In isosceles trapezoids, the legs are congruent. The diagonals are congruent, so this diagonal equals this diagonal. And the base angles are congruent. What I mean by that is the two base angles on one base are going to be congruent, and then the two base angles on the other base are going to be congruent, okay? Notice still that an upper and a lower add up to 180. They're supplementary, right? All right, so prepare your questions, and I'll see you in class.